All right. For Aldol condensation, it is the reaction between two molecules of aldehyde or ketones with at least an alpha hydrogen. Now, it is a base catalyzed reaction, and at the end of the day, alpha beta unsaturated compound is produced. Now, I'll quickly show you a simple trick on how to get the product from Aldol between two molecules of aldehyde or ketones with an alpha hydrogen. So, quickly, let me show you what to do for Aldol condensation. Now, so let's say we have a carbonyl compound as CH3CHO. This is an alkanal between, and it reacts with CH3CH2CHO, propanal, ethanol. Now, Aldol condensation is base catalyzed. Usually, a strong base is usually the catalyst. Now, the products and ways to get the product is very simple. Now, the carbonyl compound with the shorter, what's it called? The shorter chain loses the alpha hydrogen. Like if the or let me just finish. Now, the carbonyl compound with the shorter hydrogen or the shorter chain lose the alpha hydrogen. Yeah, this is the alpha carbon. This is the root, the functional group. The next carbon is the alpha carbon. It loses an alpha hydrogen, and we have this. So the next thing to do, the next trick to do, is just place your CHO, this other carbonyl compound, CHO, CH2, CH3. So just place it simple like this, and rearrange this HO to OH as a trick. Then the alpha hydrogen that was lost, place it here, and you had it. So this compound is called an aldol. This product is called an aldol. Now the aldol here is known as beta hydroxyalkanal. So if you see the aldol 1, 2, 3, 4, 5, so it is known as 1, 2, 3. So it's 3 hydroxyalkanal. So 1, 2, 3, 4. That's 3 hydroxypentanal. That's the name of the aldol. Now on condensation, the aldol, if I should write the aldol well, so just quickly look at it. If I should write the aldol well, the aldol is going to be written as C H CH2 CHO. Then we're going to have COH H. Then we have CH2 CH3. So this is the aldol form. This was the aldol form. Now on condensation, the hydroxy group on the beta position is lost, and an hydrogen on the alpha position is lost, and we get an alpha beta unsaturated compound. An alpha beta unsaturated compound. So this condensation done so far is known as an Aldol condensation. It's known as an Aldol condensation. All right. Example 2 for this Aldol condensation is the condensation of ethanol. Now, so you see a question like this: ethanol in the presence of a base. So it might not be a base. The reaction might just carry OH minus. So, but in the presence of a base, a strong base, what will be the product on heating? Now, the product from this is definitely an Aldol condensation. Why? Because you are exposing two aldehyde molecule, two alkanal molecule to heat and strong base as catalyst. So what will be the Aldol product? So the Aldol product, as I said before, how do you get an Aldol product? These alkanals are of the same length. So basically, we get the Aldol product by quickly writing their the alkanals. So probably you should always write in the T-shaped manner. So I wrote this two alkanal in the T or L-shaped manner like that. So this guy lose the alpha hydrogen, and the carbonyl compound that normally lose the alpha hydrogen are the ones that are more acidic. So aldehyde tend to lose alpha hydrogen better than ketones, because aldehyde forms stable enolates than ketones. So aldehyde tend to lose alpha hydrogen better than ketones, and ketones tend to lose alpha hydrogen better than esters. So in case you have a cross Aldol condensation where you have a ketone and an aldehyde that are going Aldol condensation, so you know how to lose your hydrogen. So this is lose your alpha hydrogen, pardon. So this guy loses, they are the same compound, so any of them can lose alpha hydrogen. So the first alkanal lose the alpha hydrogen is what? First alkanal lose the alpha hydrogen. Then the CHO CH3, the second alkanal, you rearrange the carbonyl compound there. So rearrange the carbonyl compound makes here OH. Yes, makes it. So the alpha hydrogen lost here is added here, and we get this. So this is the Aldol. This compound is called an aldol. So this is not yet the condensation product. So the condensation product will be more like this. So the condensation product will be more like this. So I'm going to have CHO that to CH2 this now to C, yes, now to CH3. Now the OH is lost here and the H is lost here in the alpha beta position. So I have just OH on the beta position, then on the alpha I have just H on the beta position and just H there also. So I lose H here, I lose H here, so I lose OH here, pardon, I lose H here, OH here, I should circle it, OH here and H here also. So I'm going to have more like a double bond. So this is the Aldol product. That product is called an alpha beta unsaturated ketone or alpha beta unsaturated aldehyde. While an Aldol is known as a beta hydroxy aldehyde or a beta hydroxy ketone. Usually Aldol is beta hydroxy aldehyde. So those others have to carry out Aldol condensation. What about for Aldol condensation without alpha hydrogen or condensation of two alkanals without alpha hydrogen? Condensation of two alkanals without alpha hydrogen. Condensation of two alkanals without alpha hydrogen. Now for condensation of two alkanals without alpha hydrogen, let me use benzaldehyde. Benzaldehyde, two molecules of benzaldehyde now catalyzed in a base. Now anytime two aldehyde molecules without an alpha hydrogen react in the presence of a strong base, the reaction it tends to undergo is known as Canizzaro's reaction. So Canizzaro's reaction is the base catalyzed reaction of two aldehydes in the presence of a base. Now the aldehyde must lack an alpha hydrogen. So this aldehyde lack an alpha hydrogen, it is benzaldehyde. So since it lacks an alpha hydrogen, it will undergo Canizzaro's reaction. So what is the Canizzaro's product? Now the Canizzaro product of this reaction is going to be this. Now one molecule of the aldehyde will be oxidized to the alkanoic acid form, while the other molecule of the aldehyde will be reduced. So Canizzaro's reaction is more like a redox reaction. So Canizzaro's reaction is more unlike a redox reaction. So this is an example of Canizzaro's reaction. I'll do one more Canizzaro's reaction and one more Aldol condensation. So another example of Canizzaro's reaction is seen in methanol. Yes, is seen in methanol. Another example of Aldol condensation is seen in methanol. So methanol is HCHO. That's methanol. No alpha hydrogen, as all the hydrogens are attached to the carbon carrying the functional group. So no alpha hydrogen. So if two methanol molecules should react in the presence of a base, catalyst, it will undergo Canizzaro's reaction. So I'm going to produce HCOO minus an alkanoic acid or its derivative plus methanol. So methanol undergoing undergoing Canizzaro's reaction in presence of a strong base as catalyst, I'll get methanoic acid or methanoic acid derivative and methanol. So it's more like a redox reaction. So one of the methanol is oxidized, oxidized to the alkanoic acid group. One of the methanol is oxidized, then one of the methanol is reduced to the alcohol form. So this is an example of Canizzaro's reaction. One more for Aldol condensation before we go. One more for Aldol condensation. This is a trick. So subsequent videos I'll show you the mechanism. This is more a trick to get Aldol product. Now, one more. I'm going to do CH3, CH2, CHO. This propanone. Two of it. Two propanol in the presence of a base. Now, at first, what did I say you should do? First, you write they are of the same chain length, so no one is shorter. Usually, shorter chain length is better losing, or they better lose alpha hydrogen. So alkanals with shorter chain length or alkanones with shorter chain length better lose alpha hydrogen than the ones with longer chain length. So they are of the same length, two propanol molecule, or it is trivially called propionaldehyde. Propionaldehyde. That's a trivial name. So propanaldehyde, propion, I think there's an N there. Propanaldehyde. So now I tell you, you write one of the one of the aldehyde molecule, then you write the other in at the alpha position. So this is alpha position, is beta position, because the carbon next to the functional group is alpha, the next carbon is beta. So you write it at the alpha position, CHO, the second aldehyde, coming down to CH2, then CH3. So how do I tell you to write your product? Lose alpha hydrogen on the straight one, so it loses an hydrogen. Then the hydrogen comes here. Then rearrange this one to be OH. So this is my Aldol product, not yet my condensation product. That is my Aldol product and not yet my condensation product. On condensation, I'm going to lose the OH here. So the OH there, I'm going to lose it. I'm going to lose this OH and I'll lose H on the, what's it called? On the beta, on the alpha position. So I'm going to have, in general, I'm going to have a CHO, then C, I'll lose H. This place has a CH3. So I have C, now I have just H now. Then I have CH2, then I have CH3. Then I will create a double bond here. So this is an alpha beta unsaturated aldehyde, which is the Aldol condensation product. So the overall reaction leading to the condensation product is most times called Croton's condensation. Croton's condensation. So I think I will perform one cross Aldol before I let you go. One cross Aldol between an aldehyde and a ketone. Cross Aldol. So I'll retain propanal, pardon. I'll retain propanal. Then I will react propanal with acetone or propanone, as it is called. So with propanone. So this is propanone. Okay. Now on Aldol condensation. So what you do, I said the alkanal is the guy that loses alpha hydrogen better because it is more acidic. So the alkanal loses alpha hydrogen better because it's more acidic. So I'll lose the alpha hydrogen here. So this is functional group alpha carbon, beta carbon, functional group alpha carbon. So this is C, so I write it CHO, CH3, CH2. So I write the propanal. Then I write the propanone in a way that it's going to attach itself to the alkanal. So this is the way it's going to be better like this. Let's say it's going to be now CH3. Now, pardon. So I'm going to write it in a way that's going to attack. So it's going to be CO, CH3, CH3. Okay, better still. Now the alpha hydrogen lost here is now used to form OH here. So this one is kind of different. It's to form OH here, and you have my Aldol product. As simple as that. I have my Aldol product, not my condensation product. On condensation, if you are following us, on condensation, so if I write this compound for you in chemistry, it's going to look like something like this. It's going to be something like CH3. Let me start with the functional group. So it should be something like CHO, CH. Okay, I will have CH. So let me take this methyl group up, then I'll take this C. Now that C has another methyl group, and it has the C has OH. So let's say this is the C. It has OH. It has methyl group. So I write it like OH. Yes. So this is the Aldol product. So let me take this one off, or let me Yeah, this is the Aldol product I got from the condensation of propanol and propanol. This is the Aldol on condensation. On condensation, yeah, I didn't put my H here. It's an H. On condensation, I lose the H and the OH at the alpha beta position. So losing the H and OH at the alpha beta position leaves me with something like this. Leaves me with something like this. So this is called, oh, just a double bond, pardon me. So this is called a alpha beta unsaturated aldehyde. Until the next video, I would like you to like, share, and subscribe. If it is helpful to you, quickly subscribe. It is helpful, it is needed that you tell your friends which are also in need, like you just did, and it tells the algorithm that this video is very relevant and show people of your type more of this. So God bless you. It's a bye.